Okay, so for question 1, log to the base a third of 27 is equal to x. So I am going to write a third to the power of x is equal to 27. Okay, so I need to work out what x is, and so I am going to put a third to the power of x, so 1 to the power of x over 3 to the power of x. I'm just going to put this bit in brackets here so you know I've put it to the power of x. Okay, and that's equal to 27. Right, 1 to the power of anything is just 1, so that's going to be 1 over 3 to the power of x. Now, since I have 3 to a power here, I'm going to look at 27 and decide what's 27 to the power of, and that's 3 to the power of 3. Okay, so now I'm going to bring this up to the top, so my power is going to become negative. So 3 to the power of negative x is equal to 3 cubed. Therefore, negative x is equal to 3, so x must be equal to negative 3. Right, for b, I'm going to do something similar. So 16 to the power of x is equal to 32. Alright, so I know that 16, I can't think straight out of what 16 to the power of is to get 32. But I know that both 16 and 32 are powers of 2. So I'm going to write 16 as 2 to the power of 4. And I still have my x. And that's equal to 2 to the power of 5. It's 2 times 2 times 2 times 2 times 2 gives you 32. So therefore, 4x must be equal to 5. So x is equal to 5 over 4, or you could write that as 1.25. Okay, so it's the fourth root of x, and then it's put to the power of 5. Okay, so on to question 2. We're solving this one. So have a look at what you have and have a think about how you could work with it. So I would suggest rearranging it so we no longer have this on the right hand side. So I'd say log to the base 5 of x minus 2 plus log to the base 5 of x minus 6 is equal to 1. Okay, so now I've got adding logs here, so I can multiply. So log to the base 5 of x minus 2 times x minus 6 is equal to 1. And now I'm going to get rid of my log, so I can write x minus 2 times x minus 6 is equal to 5 to the power of 1, so just 5. Now to solve that, I will need to multiply this out and simplify it. So it should get us a trinomial. So x squared minus 6x minus 2x plus 12 equals 5. Rearrange it so everything's equal to 0. So x squared minus 8x minus plus 7 is equal to 0. And then I'm going to get my factors. So we've got x, multiply to get 7, add to get negative 8, so negative 7 and negative 1. So x is equal to 7 and x is equal to 1. So my two solutions there. Okay, on to question 3. I'm just simplifying this, so I'm seeing if I could perhaps write them using powers, or I'm going to try and maybe simplify them by using some of my rules of logs. Okay, so I've got log to the base 9 of 3 minus log to the base 9 of 6. So I could, if I like, write that one as a division. So that's log to the base 9 of 3 over 6 plus log to the base 9 of 18. So now I can write that as a multiplication. So that's log to the base 9. 3 over 6 is a half. So it's a half times 18. Okay, so that's the log to the base 9 of 9. And 9 to the power of 1 gives you 9. So that's just simplified to 1. Okay, now question 4. This is one of our E questions, I like to call them, so your natural log questions. So have a read through. I'll give you a moment to do that. I'll give myself a moment to do that. Okay, so in 2006 we've got our initial population as 61 million. So N0 represents our population in 2006, so that's 61 million. T represents our time, and let's call r our rate of increase. So that's written as a decimal, so we've got 1.6% here, so we're going to write that as a decimal, and that will be 0.016. Okay, so then t is our time, so if it's in 2020, that is 14 years after 2006, so our time is going to be 14. Okay, so n is equal to n0 e to the power of rt, so I'm just substituting n. So n is equal to 61 e to the power of 0.016 times 14. So you do all of this on your calculator. So just type in 61, second function, your ln button, and then I would put 0.016 in times 14 in brackets, and you should get n is equal to 76.3 million. Okay. Now for part B of that, it says in 2006 the population of Scotland was approximately 5.1 million, so N0 is 5.1 million. With an annual rate of increase of 0.43%. So 0.43%, which as a decimal is 0.0043. Assuming this growth rate remains constant, how long would it take for Scotland's population to double in size? So we're looking for t equals question mark. So we don't know what the time is, and that's what we're looking for. Alright, so we're going to write down our formula. N equals n0 e to the rt. I know that the initial population is 5.1 million, and I know that the new population is going to be double that. So that will be 10.2 million. So 10.2 equals 5.1 e to the power of 0.0043t. Okay, so I can divide both sides by 5.1 here, so I would get 2, obviously because it was doubled to begin with, so 0.0043t. My t looks quite big there, so I'm just going to make it smaller so it looks like an actual power. Okay, so now I know that e to the power of this equals 2, so I can use my logs to work it out. So log to the base e of 2 equals 0.0043t. So then I can just use my scientific calculator and work out what log to base e of 2 is and divide it by this number here. So I would type in ln of 2, get my answer, and then divide by 0.0043, and we should get t equals 161.2 years, and that is my answer. Okay, right, so moving on to our next question then. This is one of these ones where you're working out A and B, so you're working kind of backwards using substitution. I hope that's what you're thinking. So y equals log to base 3 of x. I am looking for my values of a and b. Alright, so let's have a think. I'm going to pause it to think for. Alright, so I'm going to substitute in my first coordinate here. We've got a, 0, so that's x and that's y. Now when you pick y as 0, that's quite useful because anything to the power of 0 is going to be equal to 1. So 0 equals log base 3 of x, and hold on a second, forgot my line of thought. So log to base 3 of a, I forgot to put an a in for x. Okay, let's just rub that out and replace x with a. Right, okay, so log to base 3 of a, so I know that 3 to the power of 0 is a, so a is equal to 1. Okay, so that's quite straightforward. So then on to b. Sorry, I'm looking for b, not on to b. So now I know that 27 and b. So log to the base 3 of x, so x is 27 this time, is equal to b, because our point is 27. B, and this is x, and this is y. So I know that 3 to the power of b is 27. So 3 to the power of what gives you 27? Well, that's going to be the cubed root of 27. No, that's just me thinking about it. B is just 3, okay? Right, so now on to B. It says to sketch the graph of the same graph, but we're taking away 3 from it. Alright, so what we're going to do is we're going to write our two coordinates down. We've got 1, 0, and we've got 27, 3. Now, when we're transforming this graph, it's pretty much an f of x take away 3. So we're just pretty much shifting the graph down by 3. Okay, so let's have a look here. Think about that for a moment. So we've got log to base 3 of x plus 1. I almost forgot about that. So x plus 1. So when we've got it in brackets like that, that means you're moving the graph to the left by 1. And then this one here is a vertical translation, so you're moving it down by 3. So this coordinate here will become 0. And this coordinate would become negative 3. For the second one, we are moving the graph to the left by 1, so 26, and the second coordinate will become 0. Okay, so you're drawing a graph of the same shape, but you're just drawing it further down and a little bit to the left. Okay, so 0, negative 3, let's just pretend that that's this point here. Now, obviously when you're doing this in your exam, I would expect you to draw the graph. Maybe you know, you have to draw the original and then draw that one, or you could just draw the actual graph itself. Okay, so I'm going to move this writing down a little bit here so I can fit it on. Now, I'm doing this on a graphics tablet, so it's not going to be particularly neat, so I'm just going to forewarn you in advance about that. So I do apologize. It should be a nice smooth line, so let me try and fix that a little bit. Oop. Made a bit of a mess of that. Let's go again. Right, not a brilliant graph drawing, but anyway, you get the point. So it should look very similar to this graph, except for it's moved to the left by 1 and down by 3. Okay, so moving on to question 6 then. The graph opposite illustrates this law here. Find the values of k and n. Okay, so we're pretty much using our straight line graph and our rules of logs to work this one out. Okay, so first off, we're going to write down what our gradient is and what the equation is of our straight line. So y is mx plus c from National 5. Our gradient is going to be 7, so this point here is 0, 4. So 7 minus 4 over 6 minus 0. So we're going to get 3 over 6, which is a half. Okay, so y equals a half x plus my y-intercept, which is 4. Right, so what I'm going to do now is I'm going to use my rules of logs, and I'm going to take the log of both sides of this equation. So log to base 2 of k x to the power of n. Now this is not something you have to show, but I like to work it out from scratch every time, just because it's fairly easy to do and it makes more sense to me. Okay, so plus log to base 2 of x to the power of n. Right, so I am going to tidy that up a little bit. Trying to have your x first, so log to base 2x plus log to base 2k. Okay, so what we're going to do is write your other equation underneath, and then you can just equate like for like. So this is your x, and this is your x, which therefore means that n and a half are the same. So n equals a half. And log to the base 2 of k is a term on its own, and 4 is a term on its own. So log to base 2 is equal of k, I should say, is equal to 4. So k is going to be 2 to the power of 4. So k equals 16. Okay, so there's our two values And that's our homework completed. I'm going to write in marks just now, and then I'll show you where they go. Okay, so the homework is out of 25, so I'm going to go for 2 marks on this one. Obviously 1 for your answer, and 1 for some form of working. I'm not really, I don't really mind how you set it out. You may have done it differently than me, so that's 4 marks. The second question, I'm going to give you 1 for writing it like this, so bringing your logs together, 1 for getting it equal to 5, 1 for rearranging it and factorizing it, and 1 for your solutions. So that one's worth 4 as well. Then this one, I am going to give you 3 marks. So I'm going to give you 1 for your initial simplifying, 1 for bringing it to this, and 1 for your answer. For here, I'm going to go with 2 marks here. So 1 for substituting in, 1 for your solution. Once again, 1 for substituting in, 1 for getting it in terms of a log, and 1 for your answer here, so that's worth 5. Here we are going to go for 1 for A and 1 for B, so that's worth 2. So that one's quite similar to your assessment question. And for this one, I'm going to give you 1 for each of your points and 1 for your shape, which is hopefully better than mine. So that's worth 3. And on to our last one then, I'm going to give you 1 for N, obviously 1 for K, and I'm going to give you 1 for expanding this out, and 1 for kind of doing, I guess maybe 1 for kind of getting your, this bit here. Okay, so that's worth 4. So your total is 25 marks. Hopefully be aiming to get about 20 of those marks.